So now we study about the parallel combination. Parallel means what? Arranged resistance are arranged like this, parallel way. Okay. So here the first end of all resistors. The first end of all resistors means, so all these resistors end is are joined at one point. Okay, joined at one point, and the last end of resistors to another of the circuit. Okay, so all these ends are joined at one point, and here all these ends are joined at one point. Okay, such type of combination is known as a parallel circuit. We can increase the number of components in the circuit as required. So according to the need, we can increase the components. Components means what? Like resistance or switch, battery or bulb, wire, all these things in the circuit. So three resistors R1, R2 and R3 have been joined in a parallel combination. So everything arranged in a parallel combination. In the circuit, battery, this is the battery, and a switch, this is the switch, ammeter, A is the ammeter right here, A means ammeter, this is battery, K is the key, switch, and V is the voltmeter right here, voltmeter. Okay, have been added in a parallel circuit. In a parallel way it is arranged. Okay, so each resistor has the same potential difference, but the amount of current flowing in each resistor is different. Okay, but the voltmeter is only one is connected na for everything. That means what? So all the three resistor has the same potential difference, but in each resistor different flow of current is there. Understand? So here if in resistor R1, R2, R3, the amount of current flowing we represented was I1, I2, I3 respectively. Then according to Ohm's law, so Ohm's law we can write in many ways. V is equal to IR, or we can write also R is equal to VI, or I is equal to V by R. So in so many ways we can write a Ohm's law. Ohm's law is very very important. After that, parallel combination and series combination is important in this lesson. Okay, so here when we see, so in R resistor current is flowing, we take as I1, R2, I2, R3, I3. Okay, so according to Ohm's law, according to this one parallel combination, we take as I is equal to V by R1. So I2 is equal to V by R2, I3 is equal to V by R3. So before we have taken here V as a common, because potential difference is, here you see series combination, potential difference is different in each resistor. Okay, but flow of current is same. Okay, difference you see. But in the parallel combination, what is the difference? Potential difference is same, but the flow of current is different in each resistor. Okay, so that is why I1, I2, I3. But in the series combination we have taken as a common V1 and V2 and V3. Okay, so if the equivalent according to Ohm's law, if I1 we are taking here means, so it becomes V by R1. Okay, if the equivalent resistance of the three resistor is R, then I is equal to V by R. Okay, if the resistor everything is same means V by R. But I is equal to I1 plus I2 plus I3. In a parallel circuit means what? In the each resistance, the flow of current is different. That is why I1 plus I2 plus I3. But the flow of current in three resistors, it is equal to the equivalent current. Like na 9 is equal to 3 plus 3 plus 3 na. So like this. Okay. So in the above equation, V by R, I is equal to V by R na. So V by R1 plus V by R2 plus V by R3. So V. So that is why 1 by R, 1 by R1 plus 1 by R2 plus 1 by R3. Because potential difference is same in all the three resistors na, but flow of current is different. Yes. So as you have seen, the equivalent resistance in a series combination is greater than the largest resistance in the circuit. Okay, so in the series combination, the equivalent resistance in a series combination is greater than the larger resistance in the circuit, but in a parallel combination the equivalent resistance is lower than the smaller resistance in the circuit. Okay, the equivalent resistance means what? All the resistance together is lower, very low than the smaller resistance in the circuit. Underline these points. Okay, now Kirchhoff's rule, understand? When you take the Kirchhoff's rule, okay, so now you see according to diagram, current I means current passes through a point A. Okay, so arrow mark like this means going this side, and then branches out in three paths, I1, I2, I3. Current is flowing I, but it is branched into two, I1, I2, I3. So that is the one. This is the equivalent. Okay, so these three are equal to this one, because this how much current is flowing, that much current is divided into 3, but these three currents are equal to this one. So that is why I is equal to I1 plus I2 plus I3. So here it becomes I1 it becomes means minus I1 minus I2 minus I3 is equal to 0. So at point B, the three branched paths join together and the value of current becomes equal to the value at point A. So for example, the same current which has gone this way, again coming back and meeting at one point and coming this way. That means all these three are equal to this one at the point B. Okay, so I1 plus I2 plus I3. So these three are equal to now I. Now I1 plus I2 plus I3 minus 1 is equal to 0. So here what is the Kirchhoff's rule? So this is the mathematical representation of a Kirchhoff's rule. Therefore, according to Kirchhoff, the algebraic sum of current, sum means total, current flowing to any point or junction, junction means meeting point. Na? So this is the junction, meeting point. Okay, circuit is equivalent to the sum of the current flowing out of that point or junction. So here they are telling this I current is the equivalent current. This is the equivalent current is equal to the sum of these three currents. Okay, at this point, going out of this point. Okay, so according to Kirchhoff's, the algebraic sum of current flowing to any point or junction of a circuit is equivalent to the sum of current. Equivalent to the sum of current means I1, I2, I3 flowing out of that point or junction. There is no storage of current at any point in the circuit and it is constantly flowing. So in the wire, in the circuit, anywhere current is not storing. The continuously current will be flowing. If the current stores means after the current cut also we can have the current, na? But here no current, because there is no always the storage of current in the circuit. Always the flow of current will be there. Okay, this rule of Kirchhoff's is in accordance with the law of conservation of charge. Conservation means what? Saving. How much current is flowing, that much current is used to use the for the electric, to glow the bulb, to run the fan, to run the mixie or grinder or TV or anything. Na? So how much current is flowing, that much current the electric appliances use. Electric appliances means like bulb, fan or mixie, grinder, all these things they use. So that is the conservation of energy. The first rule of Kirchhoff's is also known as a junction or nodal rule. Junction, Kirchhoff's rule also we can call it also as a junction or nodal rule of current. So this is the Kirchhoff's rule. That is why we call it as a 0. That means how much current flows, that much current is used. So the flow, this much current. Now for example, from the main box current is coming to all the rooms in the house. The main box, the current flow is equal to the all the current where all the rooms are using. How much current flow, that much current we use it. Okay, so this is the Kirchhoff's rule. Understand? So equal series combination and parallel combination. And what is the plus point for the parallel combination means here, okay, so if one resistance break also, no problem, other circuits, other lines will get the electricity. But in the series combination here, if one is cut also, current flow will stop everywhere. But here if one is break also, current flow will be there. Okay, because it is arranged in a parallel combination. So one is cut off also, so these two current will flow in these two. Okay, so like this parallel combination. But this is important. Okay, thank you students.